All right, we're going to finish this 1985 AP Calc BC multiple choice. Okay, so let's dive right in. No wasting time here. Equation of the line normal to the graph of y is x cubed plus 3x squared plus 7x minus 1 at the point where x is equal to -1 is... So this is asking about equation of the normal line. Normal line is perpendicular to the tangent line. Okay, so let's find the slope of the tangent line first. Slope of the tangent line, that is derivative. Y prime is equal to what? Power, that's 3x squared plus 6x plus 7. Okay, we evaluate it at x equal to -1. That's where we want it at. So it'll be 3 minus 6 plus 7, which is 4. Okay, this is the slope of the tangent line. So the slope of the normal line is the negative reciprocal. So let me write it like this. 4 reciprocal, add a negative sign. So this is -1/4, okay? So this is the slope of the normal line. We need equation of the normal line. So we have a slope, we need a point. When x is -1, what is y? Y would be -1 plus 3, which is 2, minus 7, that's -5, minus 1, that's -6. So it'll be y plus 6 is -1/4, x plus 1 is point slope form, right? So we have to change it up a little bit. Let's multiply by 4, -4 on both sides even. We can do that, right? So -4, y plus 6 is equal to x plus 1. Let's distribute over here, -4y minus 24 is equal to x plus 1. So it would be what? We can move this y to this side, so it'll be x plus 4y, and move this 1 to this side, it'll be minus 25. X plus 4y is minus 25, that's E. Okay. dy dt is -2y, and if y is 1 when t is 0, what is the value of t for which y is equal to half? dy dt is this, so let's find y of t. That's just the antiderivative, so that's just power rule, minus y squared plus c. Y is 1 when t is 0, so y of 0 is 1, which is negative, I did this wrong, I think. So, sorry. This is dy dt is -2y. This is not t, sorry. So, we need to do, because I recognize that. This should be E. What was I saying? Separation of variables. So, it'll be dy, let me just rewrite the original problem, is -2y. Move the y's all on one side. Move the t's all on the other side. Okay? So dy over y is -2 dt. Now we integrate both sides. So log y is -2t plus c. Or we can write it as y is c e to the -2t power. Okay? Now we can plug in when y is 1, t is 0. Or when t is 0, y is 1. So y of 0 is equal to 1. Here, now we can do that, is equal to c e to the 0 power, which is just c. So c is equal to 1. So y is e to the -2t. Okay, so what value of t is y is equal to half? So half is equal to e to the -2t. Okay, so let's log both sides. Ln of half is equal to -2t. So t is equal to ln half over -2. Well, ln half is ln1 minus ln2. ln1 is 0, so it'll be minus ln2 over -2, or it's just ln2 divided by 2. 33 is C. Okay, this one, they most likely don't ask this anymore on the AP Calc BC. This is about surface area. But if you just want to know how to solve it, it's 2 pi integral f of y squared 1 plus dx dy squared dy. So that's the formula. So the integral is from 0 to 1. F of y is just y cubed. Dx dy is 3y squared. So we put that there, and then we simplify, or it would be 9y to the 4th dy. So that would be a. Looks like, okay. This one also, they probably, I don't know if they asked this actually. Let me not more confidently say that. This one is the shell method to find volume. For sure they'll ask about the disk washing method. I don't know about the shell method anymore, but in case they do ask it, or even if you do know how to use it, great. The region in the first quadrant between the x-axis and the graph, the sky, is rotated around the y-axis. So we know how this looks. It's a parabola, okay? And then we can even get the zeros of it by factoring x from both terms. So it's x times 6 minus x. So it is, there are zeros when x is 0 and x is 6. Something like that. I'll open something like that. We can even guess that the max is at 3. We can even differentiate if we want to and find out that the max is at 3, okay? We don't really need to know that though here, but this is a sketch, okay? The volume of the resulting solid of revolution is given by, so here the problem with the disk washer method is usually when we revolve around a vertical axis, we integrate in terms of y. So we take a cross section perpendicular to the axis of rotation. This one it's not impossible, but it'll be more complicated because you'll have to do an R out and an R in. Versus if you do the shell method, you take a cross section parallel to the axis of rotation. Remember, it's 2 pi integral r h dx. That's how I remember. Okay, r is the distance from the x-axis. Okay, so that's just x, no matter what point on this curve, and h is the height of the shell. So h is just the function 6x minus x squared. Okay, so we set the integral like this. Okay. Moving on. Okay, this one I also did beforehand already, or a little bit of it. We have the integral from -1 to 1, 3 over x squared dx. Here you can clearly tell that it's an improper integral because the interval is from -1 to 0, but this guy is undefined at x is equal to 0. So it's an improper integral. So technically we had to split it up as integral from -1 to 0 of 3 over x squared dx plus integral from 0 to 1, 3 over x squared dx, and then 0 from the right, 0 from the left, specifically, okay? We could do it a little simpler because we know that this is an even function, so we can do, instead of -1 to 1, is 2 integral from 0 to 1. But remember that property for even functions? Okay, so this, if we find the antiderivative, that's 3 into 2 make it 6, so it'll be 1 over x squared dx. So the integral of 1 over x squared is minus 1 over x. We value it from 0 to 1. When you plug in this lower limit, 0, it'll blow up the improper integral, right? So it'll go to infinity. Non-existent. Or technically it should be written as divergence. This one, I'm very confident that they don't ask this in BC anymore, so I'm just going to skip it even. Plus I don't remember off the top of my head how to do it. Okay, limit as x goes to infinity of this guy. This guy, we need to use the trick where, since this is x to some x power, we need to log it. Let's call y is equal to 1 plus 5e to the x to the 1 over x power. So if we log both sides, so this is similar to logarithmic differentiation. It'll be log of 1 plus 5e to the x to the 1 over x power. Okay? Properties of logs, we can move this out in front. Okay? So let's find the limit of this guy. Limit as x goes to infinity, we just keep the original guy, okay, of ln of 1 plus 5e to the x over x. When we do this, When we plug in infinity, what do we get? We get infinity over infinity. That's an indeterminate quotient. So we can do L'Hopital's rule. Okay. The top, we would get 1 over 1 plus 5e to the x. We're taking derivative of the top, by the way, times derivative of the inside. That's derivative of the inside is times 5e to the x. Okay. And then derivative of the bottom is just 1, so I'm just going to not write that. Okay. So now we have this. Okay. So if we do, if we plug in x is infinity here, we still get infinity over infinity. So we can do L'Hopital's rule one more time. Okay, so derivative of the top, so derivative of 5e to x is just 5e to x. Derivative of bottom, derivative of 1 and 0, derivative of 5e to x is just 5e to x. These would cancel, so we're to 1. So limit as x comes to infinity of 1, that's equal to what? Remember, this is ln(y), so we just have to exponentiate the result here. So it'll be e to the first power, which is e. Okay, so 38 should be c. Yes. Okay, that's how we do that. The base of a solid is the region enclosed by the graph of y is e to negative x. The coordinate axes and the line x is equal to 3. If all plane cross sections perpendicular to the x-axis are squares, then its volume is what? Okay, so let's sketch the region. How does e to the minus x look? It looks like this, right? The coordinate axis and the line x is 3. So x is 3 is over here. So this would be your region, okay? Cross sections perpendicular to the x-axis are squares, so it'll be a square here, it'll be a square here, a square here, so on and so forth like that, okay? So we want to integrate, what's the area of the square? It's the length of the side squared, dx, okay? That's how we find the volume. So the volume is integral from 0 to 3, that's where the region starts and ends. What's the length of the side? What's this length here? That's just e to the minus x. Square that, dx. So that's integral from 0 to 3, e to the minus 2x dx. We can write it like that. So this is just minus half e to the minus 2x. We evaluate from 0 to 3, which is negative half, e to the minus 6 minus 1, okay? Which is 1 minus e to the minus 6 over 2. So it looks like 39 is A, yes. Okay, here it looks like I solved most of it already. If the substitution u is x over 2 is made, the integral of this guy becomes what? Okay, so let's change our limits of integration. When x is 2, u is 1. When x is 4, u is 4 over 2, which is 2. 1 minus x over 2 is u, so 1 minus u squared. And then we need to substitute this dx and this x, okay? So we can differentiate here, both sides. Du would be half dx, meaning dx is 2 du. So dx is 2 du. How about x? Well, we can just rewrite this definition as 2u is equal to x. So like that, okay? Then we can cancel here. So we get 1 minus u squared over u du. Okay, so it looks like 4t is A. Okay, that's how we do that. 5 more problems, let's go. As soon as I can flip the page. Okay. And as soon as I put this below everything, okay, give me a few more seconds. Length of the arc, this guy, from 0 to 3. Arc length formula, hopefully you remember how to do that. Sorry if the video jumped, I had to get a piece of scratch paper. So arc length, that's just L is integral of 1 plus dy dx squared dx. Okay, so what is dy dx? Dy dx equal to, we just do the power rule. It'll be 2/3 times 3 halves, which is 1, x to the half power. So dy dx squared is just x. So 1 plus dy dx squared is just 1 plus x. So our integral is from 0 to 3, square root of 1 plus x dx, okay? So this is just, what would this be? This would be, this is to the half power, so it will be 2/3, 1 plus x to the 3 halves. I'm just doing the substitution in my head. Let's just differentiate to see if we get the same thing. If we take derivative of this power rule, 2/3 and the 3 over 2 would cancel. 1 plus x to the half power, that's this, times derivative inside, that's 1. Okay, good. Evaluate from 0 to 3, which is equal to 2/3. 3 plus 1 is 4 to the 3 halves minus 1. Okay, so this is 2/3. Square root of 4 is 2. 2 cubed is 8, which is 7 times 2, which is 14 over 3. Okay, so I believe 41 would be C. Yes. Okay. Coefficient of x cubed in a Taylor series for e to 3x about x is equal to 0 is, well, remember how e to x looks? It's, what the Taylor series is, it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay? And so on and so forth. So how about, let me draw a line there. It's x to the 3x. Okay? The x cubed term we want, so let's just go there. So it'll be 3x cubed over 3 factorial. Okay? Instead of x, it's 3x. So like a function, wherever there's an x, you plug in 3x. So 3x cubed over 3 factorial. Okay, so what's 3 cubed? That is 27. Okay, so 27x on top over 6 on the bottom, which is equal to, if we divide by 3 on top and the bottom, that would be 9x over 2. Okay? Which, so the coefficient in front of, sorry, this is x cubed. So the coefficient in front of x cubed is 9 halves. Let f be a function that is continuous on a closed interval -2 to 3, such that f prime of 0 does not exist. Maybe that's key. F prime of 2 is 0. Okay, so f double prime of x is less than 0 for all x except 0, because I'm sure it does, because if the first derivative doesn't exist, I'm sure the second derivative cannot exist there, right? Which of the following could be the graph of f? Okay, so f by the second derivative, it's concave down because the second derivative is always negative, okay? So we need something that's always concave down, okay? So I see here, this is concave up, so we can eliminate B. Here it's concave up, we can eliminate A. This looks like there, it's all concave down. So those look fine. F prime of 0 does not exist. Well, here f prime of 0 exists. There's a slope of the tangent line there. Okay, and it seems continuous there. It doesn't show that there's a hole there, right? Yeah, f is continuous from -2 to 3, so since it's continuous there. And there's no sharp turn, there's no vertical tangent. The derivative exists there, so it cannot be C. Okay, so we're left with these two. It tells us that f prime of 2 is 0, so the slope of the tangent line at 2 is 0. That's both the case, okay? Okay, so now the thing is, it's always concave down. Looks like these two are. Oh, the thing is, this is discontinuous there. There's a jump. Right? This is continuous, but the derivative doesn't exist, so it should be E. Okay, yep, that's right. Okay, two more. At each point x, y on a certain curve, the slope of the curve is 3x squared y. If the curve contains the point 0, 8, then its equation is slope of the curve, that should mean dy dx is 3x squared y. So let's use separation of variables to solve this equation. So let's solve for the equation y. So dy over y is 3x squared dx. Now we integrate both sides. This would be ln is x cubed plus c, or y is c e to the x cubed. Okay. They give us the initial condition at 0, 8. So 8 is equal to c e to 0. So c is equal to 8. Y would be 8e to the x cubed then. Is that what they're asking for? 8e to the x cubed, 44a? Yes. Okay. Last one. This clearly looks like a Riemann sum to me. If n is a positive integer, then limit as n goes to infinity, 1 over n times 1 over n squared plus 2 over n plus dot dot plus 3n over n squared can be expressed as, well, remember how the limit definition of a definite integral? Riemann sums and all that? So I wrote it over here, integral from a to b, f of x dx. Remember, it's the limit as n goes to infinity, summation of i goes from 1 to n, okay, of f of x sub I times delta x. Delta x is the width of the rectangles, b minus a over n. X sub I is the sample point, and we starting from the right endpoint. Okay, we're going to use right endpoints. All right. So, which of them is it? Okay, so right away I can tell that the problem here is actually you would think b minus a over n delta x. Oh, this is delta x. So it has to be from like 0 to 1. Well, that's not the case because this is the thing that throws you off over here. 3n over n would throw you off, okay? So you got to be careful here. So if this is x sub 1, okay, so it would be a plus delta x is 1 over n, right? 1 over n times I, which is 1. Okay, so a is 0 then, if that's the case. So the lower limit of regression is 0. So that's for all of them. That doesn't help us, okay? How about the last point over there? So it would be what? 3n over n is equal to 0 plus 1 over n times n. Actually, let me backtrack a little bit. So, before we even go to there, over here, as we said, a is 0. So, since this is the sample point, 1 over n, okay, this is 1 over n squared. So we know the function is x squared. Okay, so we eliminate everything but these two. Okay, so let's cross those out. So which one is it? Is it 3 integral from 0 to 3 or integral from 0 to 3? Okay, here, well, actually, earlier I just said that the function is x squared, so it has to be this one. And that's correct. Okay, so let me explain one more time. Okay, so where is a piece of scratch paper? We know the Riemann sum, so integral from a to b, f of x dx, that's the limit as n goes to infinity, summation of I goes from 1 to n, f of x sub I times delta x. That's the width of the rectangle. This is the sample point. Okay, so we know that since it was given in this form, okay, that delta x has to be 1 over n. Okay, and then these are all the sample points. Okay, so it looks like the function f of x is just x squared. Okay, so we eliminated half of them. Okay, or we can even eliminate this one technically, but how do we get the limits from 0 to 3 is the question probably, right? And to not get that 3. Well, we are starting from, remember, okay, so x sub I is a plus delta x times whatever I is, okay? So x1 would be a plus delta x is 1 over n, right? 1 over n times, 1. I is 1. Okay, so it would equal to a plus 1 over n. The very first point is 1 over n. So a has to be equal to 0. Okay, so that doesn't help because both these bottom limits are 0. So what about the top limit? Okay, well, it goes up all the way to 3. Okay, so maybe I can even show from here. As n goes to infinity, remember, where it's a definite interval from A to some point B. What's the very last point? It's going to be this one, right? So as n goes to infinity, the very last point is 3. Okay, and the function is f. The function is x squared. So what's inside the square? That's 3. So that's the upper limit. Okay? So that's the answer, this one. Okay? So there's no 3 from here. Okay? The function is just x squared. So it's this one. Okay? Hopefully that made sense. And that's it for this exam. Please give this video a like if you found it helpful. And please subscribe to the channel as always to look out for the next video.